So in this section, chapter 7, section 1, we're going to be using our fundamental identities. And so this is where we're going to really start working with these trig identities and showing you all the things you can do with them and how to solve problems with them. So we start out with our identities, right? You've seen this before. There are some new ones here, but really the ones that we're really going to focus on that you're going to see a lot are these reciprocal identities, which you've talked about. We know the cosecant of an angle is equal to 1 over the sine of that angle. The secant is 1 over the cosine, and the cotangent is 1 over the tangent. We also know that tangent is sine over cosine, and cotangent is the reverse, cosine over sine. And then the Pythagorean identities, we use these a little bit in some of our previous assessments, and basically you want to definitely know these. Now you're going to oftentimes have these cheat sheets during your assessments, but you want to memorize them and really start to recognize them. So when you see that sine squared theta or sine squared x plus cosine squared x equals 1, you also can see it as, the sine squared of x equals 1 minus the cosine squared x. That often is something that comes up. Or maybe cosine squared x equals 1 minus sine squared x. You can sort of treat these like algebra equations. And you can add, sine squared theta to both sides or something like that. So we're going to be doing a lot of that so that you can kind of see and learn all the different things you can do with these functions or identities. So again, you want to kind of memorize those. The even and odds and the cofunction identities, again, we'll get to that eventually. But for right now, really the top two categories are the ones we're looking at. So goal of simplifying, right? So a lot of times we're going to substitute to simplify expressions. We're going to substitute an alternative. Like if we know tangent is sine over cosine, we may substitute sine over cosine in for tangent. And again, I'm going to show you how we might simplify. So we're going to start this section here by simplifying. And most of the time when we simplify, we're going to consider potentially, in this section, we're going to consider pulling out a GCF. And we're going to consider going down to the most basic sine and cosine of things. And I'll show you what I mean. So we go to number 1, we go to simplify it, and we contemplate factoring out a GCF. We recognize that sine x is the GCF. That's going to leave you with cosine squared x minus 1. At this point, we wonder, okay, can we simplify this further? And again, when we get to the verifying trig identities, which is 7.2, you're going to know what your goal is, and so you're going to know if you need to keep going or not. Right now, you're not really sure if you need to keep going, but we do have one trig ratio, and the trig ratio is sine squared of x plus cosine squared of x equals, or not trig ratio, but like a Pythagorean identity, equals 1. And I recognize that if I just move things around, I can get this to that. In other words, for example, let's say I keep the cosine squared x on the left. I move the 1 over to this side, and I move the sine over to the other side. And I realize that this parentheses, this cosine squared x minus 1 is equal to minus sine squared x. And now I can actually multiply these together and get minus sine cubed x. And I could simplify it like that. So again, those Pythagorean identities are critical, and you want to get used to moving them, manipulating them, and moving things around. When you go to the second one, you go to factor out the GCF again. It's cosecant of x. You get cosine squared x minus 1. And again, we did like in the last problem, we knew that cosine squared x minus 1 is equal to minus sine squared x. The cosecant can be simplified to 1 over sine of x, and that's times minus sine squared of x. And I know these can cancel, leaving me with minus sine of x. And again, pretty cool, right? So again, we can just kind of break things down by using our Pythagorean identities, potentially converting cosecants and things like that to something, to sine and cosine. 3 and 4 are a little bit more obvious what you need to do. In 3 and 4, we're multiplying, 1, 3, we're multiplying secant, cotangent, and sine of theta. Right now, that doesn't seem like it can be simplified very easily, but if I convert the secant to 1 over cosine theta, if I convert my cotangent to cosine theta over sine theta, and I convert my sine, well, I don't have to convert it, it's just sine theta, right? These are all multiplied together. My cosine thetas will cancel, my sine thetas will cancel, leaving me with the solution of the simplified version, which is just 1. So again, breaking it down to sine and cosine is often the easiest way to go about it. And then the last one again, I know that I have a Pythagorean identity that I can apply to this. I know that 1 plus tangent squared theta is equal to secant squared theta, or x. And then this is your cotangent squared x. So it's a good way of starting. Again, you might think, well, am I done here? Well, as long as I can convert this to sine and cosine, I think I'm going to keep going. So I know cotangent squared theta is cosine squared, or theta, or x, over sine squared of x. And I know that the secant is 1 over cosine squared x. And so I realize that these cancel, leaving me with 1 over sine squared x, which is completely valid. Oftentimes we'll say, well, let's not make it a fraction, and I know that 1 over sine squared x is also cosecant squared x. Now tomorrow, or not tomorrow, but when we get to section 7.2, it'll be more obvious what you need to do, because we're going to say to you, verify, okay, that sine of x times cosine squared x minus sine of x is equal to minus sine cubed x. And what you're going to do is you're going to do all this work. You're going to kind of keep going from step to step to step until you can get the left side to match what they asked you for. And so it's much more obvious in the next section what you need to do and when it's time to stop. Again, right now we're just learning the skills to be able to do that next section. We're learning all the things we can do with simplifying. You know, we can factor out a GCF, we can convert to sine and cosine, we can add in some Pythagorean theorem, some Pythagorean identities, or sub them in. Now, simplify by factoring. So once again, I got to that other page and I already sort of factored out a GCF on those. We're going to keep simplifying by factoring. Again, this is like a difference of squares. I know that this is secant of x minus 1 times secant of x plus 1. And so I've already factored it. This is fully factored. I can't factor it anymore, and so I'm done there. Okay, all they want me to do here is factor. In this one, it's kind of interesting because I have 4 times tangent squared x plus tangent of x minus 3. Well, again, you could sort of think about this as a quadratic formula. I might do this, something that might help you. Remember when we used our x's, I can say, well, the tangent of x is u, so tangent squared of x is u squared. So this would be equivalent to 4u squared plus u minus 3. And when you think about it that way, you're like, oh, I can factor this, I can group this, right? I know my product is negative 12, my sum is 1, so this is 4 and negative 3. So 4u squared plus 4u minus 3u minus 3. And again, I factor by grouping, right? So 4u is the GCF of that group, which leaves me with u plus 1. And here, I've got minus 3, and it's going to leave me with u plus 1 again. So again, when I factor, I have 4u minus 3, and I have u plus 1. Now, all I need to do is I need to switch for my u's. I need to swap back in the tangent of x. So 4 tangent of x minus 3 times times, again, u, which is tangent of x, plus 1. And this is fully simplified, okay? And so again, it's weird, but yeah, you can kind of use all the same things you do factoring GCFs to regular equations or quadratics, factoring a quadratic by difference of squares, using the u for these other scenarios. I mean, it's definitely something that you can try. and you'll see that it starts to really work, okay? Again, I come to this next one. They want me to factor it. So when I look at this, I know that this is 1 plus cosine of x times 1 minus cosine of x. And so that's fully factored. Now, they told me to simplify by factoring, and that's what I did. This could be simplified another way. I know that, remember that there's an identity that says sine squared of x plus cosine squared of x equals 1. So if I subtract cosine of x from both sides, I'm going to get sine squared of x equals 1 minus cosine squared of x, which is this. So technically, this is also equal to sine squared of x. This is another way to simplify it, but they did tell me to simplify by factoring, and so I believe this is the answer that they want. However, just know that this and this are equal, okay? And again, right now, just follow the directions that you're given. Okay, so then I get to this last problem, number 8, and again, I see that it's cosecant squared here, cosecant here. It's a trinomial. So guess what? I'm going to use that little u value. I'm going to make the cosecant of x, or cosecant really, right? I'm going to make that equal to u, right? So cosecant is going to equal u. So anytime the cosecant is squared, it's u squared. So I have 2u squared, right, minus 7u. All right, I'll do x here, sorry. Okay, minus 7u plus 6. And again, I have to factor that the traditional way. It has a product of 12, a sum of negative 7, and I know it's minus 4 and minus 3. So when I factor this, I know it's going to be 2u squared minus 4u minus 3u plus 6. I'm going to group these 4 terms into 2 and factor out the GCF. So I'm going to get u minus 2. Factor out the GCF, I get u minus 2. And I know that my factors are 2u minus 3 and u minus 2. Again, u equals cosecant of x. So this is 2 cosecant of x minus 3. And it's cosecant of x minus 2. And here I'm simplifying by factoring, because again, they asked me to simplify by factoring. And so I'm factoring all of these things, okay? When we get here to number 9 and 10, again, it doesn't say it, but I think it follows the other instructions from the last page. So again, they want me to factor this. Now, this one's a little tougher because notice that these are not the same, right? So this might make it a little tougher for me to factor. So when I come here, I might want to use, I might want to see, is there some kind of a Pythagorean identity that works with cosecants and cotangents? And there actually is, right? So I know that 1 plus the cotangent squared x equals cosecant squared x. That's one of my identities. So if this equals this, then I can substitute for this one. I can substitute 1 plus cotangent squared x minus cotangent of x minus 3. Again, combine my like terms. Cotangent squared x minus cotangent of x, and 1 plus minus 3 is minus 2. And so now I know that I can factor this. I know, again, my product is going to be negative 2. My sum is negative 1, right? So this is negative 2 and 1. So this is going to be cotangent of x minus 2 and cotangent of x plus 1. When I multiply that out, I'm going to get that trinomial. So this again is simplifying by factoring. Once nothing is squared, once I don't have a difference of squares or a GCF to pull out or anything else, I should pretty much be done. And so I'm not going to try to simplify this any further. I'm not going to convert my cotangents to, cosine over sine. I don't need to do that. That's fully simplified by factoring. And then again, I go to my last one and I do the same thing. So again, when I look at this last one, I see secant and tangent, and these are not the same, right? But I do know that I have a Pythagorean identity that says tangent squared of x plus 1 equals secant squared of x. So I can sub that in for the secant squared x. So this is going to be tangent squared x plus 1 plus 3 tangent of x plus 1 here, okay? And so when I get to this, I'm going to combine my like terms. So I have tangent squared x plus 3 tangent of x plus 2. So again, I can use the u squared, or by now you might be comfortable enough to just pretty much know that this is similar to an x squared plus 3x plus 2 scenario. And so you can say, okay, the product is 2, the sum is 3. I know it's 2 and 1, and so it's going to be tangent of x plus 2 and tangent of x plus 1. Okay, and again, this would be fully factored, okay, simplified by factoring. So again, weird concepts, just kind of keep practicing it and you'll start to see these trig identities as more of algebra problems. And so you just want to be able to see it, recognize these identities that matter so much, because if you don't remember them or you don't recognize them on the cheat sheet, you're not going to be able to move forward with the problem. Last few answers, you're told to simplify. So now you're going to simplify using all of the methods. It might be GCF, it might be substitution, it might be factoring. You just have to determine it problem by problem. So when I get to this problem, I see sine x plus cotangent x plus times cosine x. So there's no GCF that's obvious to me to take out. So what I'm going to do is, since I have sine of x, at worst case, try to break everything down to sine and cosine, because that oftentimes is what all you really need to do. So the cotangent, I know that's cosine of x over sine of x, okay? And then I'm multiplying that by the cosine of x. So again, so far, nothing looks really great to me. I have sine of x plus, this is going to be cosine squared of x over sine of x. And so this expression is still not really very obvious what I can do. Well, maybe I should add the expression then, right? I've got in terms of sine and cosine. Maybe what I'm going to want to do here is I'm going to want to add these two together. And for me to add these together, remember that I have to give them a denominator of the least common denominator. In this case, the least common denominator is going to be sine of x. And what I'm going to do is I'm going to multiply both sides by the sine of x. Okay? So when I do that, the left side is going to become sine squared x. And the right side is going to just stay cosine squared of x. And so now I'm here. Okay? Again, it might not seem too obvious just yet, but if you remember your Pythagorean identities, you know that sine squared x plus cosine squared x equals 1. So I can replace this fraction, this numerator, with 1 over sine of x. That is a great answer. This is also equal, remember 1 over sine of x is equal to cosecant of x, which is also fine. Either one of these is a simplified answer. How far do you go? Do you end at 1 over sine? Do you end at cosecant? Well, that's going to depend on the problem in the future that you're given. Like I said, when you're really doing these, the problem will tell you where to stop. Okay, it'll make more sense once we get to 7.2. Okay, let's go to the next one, right? So here, again, I have a cosecant minus a cosine times a cotangent. So I'm going to put these in sine cosine form. So cosecant is 1 over sine x. Cosine is just, again, cosine x over 1, let's say. And cotangent is cosine of x over sine of x. So I'm going to simplify that right side. So 1 over sine x minus cosine squared x over sine x. Okay, so now I've got that. Well, I have the same denominator, so I can combine them. Remember, simplifying is changing things to lower terms or less terms. So I'm going to do 1 minus cosine squared x over sine of x. Looking good, right? Well, again, do I keep going? Yeah, because again, we know sine squared x plus cosine squared x equals 1. right? So if I subtract the cosine squared of x from both sides, I'm going to get 1 minus cosine squared x. So this numerator can simplify to sine squared x over sine of x. And again, sine squared x, that can simplify. Remember, this is like sine of x times sine of x, and the denominator is the sine of x, so I can cancel one, leaving me with just the sine of x. And so that was a lot of work to simplifying, but we did it, right? Again, we come to the next problem. When we come over to number 13, this one's going to be a little bit more of a challenge, right? Again, I see that I have my denominator. I want my least common denominator to be, it's going to be both of these denominators. So I'm going to have to multiply both sides by this LCD. And I'm going to write it here in the denominator once. So when I multiply this numerator by 1 plus cosine x and by sine x, I know that the 1 plus cosine will cancel with the denominator, leaving me with sine squared of x. When I do the same thing to the other side, right, times sine of x, I know my sines will cancel, leaving me with cosine of x times 1 plus cosine of x. Okay, so I'm going to have that expression. So right now, this is looking pretty convoluted, but what I'm going to do is I'm going to do kind of what I know how to do. I'm going to sort of try to simplify that numerator by distributing that cosine. So I'm going to rewrite it over here. So I have sine squared x plus, and it's going to be cosine of x plus cosine squared of x. And my denominator is going to stay 1 plus cosine x times sine of x. Now, I know that if I take sine squared of x and cosine squared of x, that converts to 1 because it equals 1. And I get 1 plus cosine of x over 1 plus cosine x times sine x. And I realize, oh, this 1 plus cosine x is going to cancel out, and I'm going to be left with 1 over sine x, which is totally acceptable. Or I know that's cosecant of x, which is probably the best answer here. Okay? And then lastly, I'm going to go to 14. Again, my LCD, let me kind of give myself some space. My LCD is 1 plus sine x and 1 minus sine x. So again, when I multiply by both of those, I know the 1 plus sine x and the 1 plus sine x will cancel, leaving me with just 1 minus sine x times 1. So that'll be 1 minus sine x, right? And then when I do the right side, I know the 1 minus sine x will cancel, leaving me with 1 plus sine x. So it'll be 1 plus sine x. If I simplify the top, that's going to be, I have 1 minus sine x plus 1 plus sine x, so that's going to just be 1 plus 1 is 2, minus sine x and plus sine x cancel, right? And my denominator, I could actually do the math here, right? That's a difference of squares. It's going to be 1 minus sine squared x. Now, again, I don't know if I'm supposed to stop here or not, but I know my Pythagorean identities. I know that I have one that says, remember, sine squared x plus cosine squared x equals 1. So I know that cosine squared x equals 1 minus sine squared x. So I know this could cancel to cosine squared x. And this is valid, right? I also know that the cosecant squared x is equal to, or 1 over cosecant squared x is equal to secant squared x. So this would be the same as 2 times secant squared x. And that would be another way to write this. Either one is fine. Okay? This one's a little tricky. And on our last page here, we come into something else. We come into the idea of potentially using conjugates. okay, if you guys remember how conjugates work. Right now, 15, there's nothing I can do to this. However, what if I was to multiply by the conjugate? What if I multiplied the top by 1 minus sine x and the bottom by 1 minus sine x? What would that do, or how would that improve my situation? Well, my numerator would stay 1 minus sine x. My denominator would become a difference of squares, right? I would multiply those out and I would get 1 minus sine squared x, like that. I would say, okay, well, I know, again, remember, sine squared x plus cosine squared x equals 1. So I know that cosine squared x equals 1 minus sine squared x, right? So I'm going to replace 1 minus sine x over cosine squared x. And what I'm going to do, this is kind of like tricky, but I know that when I have an expression over a single denominator, I could rewrite it as 1 over cosine squared x minus sine of x over cosine squared x. I could separate it like that. Let's see what else I can do with this. I can, start to think about, well, 1 over cosine squared x, that's secant squared x. I know that this minus sine, I could make this sine x over cosine x times 1 over cosine x. I know that this here is the same as minus tangent of x. And 1 over cosine of x is secant x. And so at this point, I think I'll stop here. Again, I can get to other points, and most of the time, we're not just going to generically ask you to simplify it. We're going to give you the original problem, and we're going to tell you to verify that that original problem is equal to, and maybe we'll have secant squared x minus, tangent x, secant x, and you'll sort of do all the work all along the way until you get there, okay? So this one, I'm not going to keep going. I could keep doing some stuff, but I think we've gone far enough, okay? Again, all we're trying to do is give you ideas to see, like, things that you can do with these trig identities, okay? These fundamental identities, what you can simplify, you can pull out a GCF, you can add them, you can subtract them, you can factor them, you can do all of these really cool things, okay? And we'll do one more. So again here, when I start this one out, it doesn't really jump out at me, I guess. So I look at this one and I could maybe multiply by the conjugate. Again, that's very helpful. So I'm going to multiply top and bottom by the conjugate, which is 1 plus sine of x. Now, the numerator becomes cosine squared x times 1 plus sine x, and the denominator becomes 1 minus sine squared of x. Now, again, remember your trig identities, right? You know that one of those Pythagorean identities is that sine squared of x plus cosine squared x equals 1. So I know that cosine squared x equals 1 minus sine squared x. So I can come over here and I have cosine squared x, 1 plus sine x at the top. And at the bottom, I can replace this with cosine squared x. And I already see the pattern. Look what's happening. These cancel. And so I'm left with 1 plus sine of x. And I would say that that's really where I want to end it. So again, just all we've really given you today is ideas, so that when you look at a trig expression, you can think of all these different things that you can do to it to get it to change, to look different, to simplify it. And when we get to 7.2, all these skills are going to be necessary for you to be able to verify those trig identities, okay?